Okay. Yeah. Shall I start?
Yes.
Yeah. Okay. Thank you. Hello, my name is Shreya Mane, and my presentation topic is greenhouse on Mars. Yeah, these are the topics. Okay. Yeah. This is the basic structure of the Mars greenhouse, which is actually I will explain first what is the Mars greenhouse. The Mars greenhouse, which is also known as the Martian greenhouse, which is refers to hypothetical structure which is designed to facilitate plant growth, and it provides a controlled environment for cultivating the plants on the surface of the Mars. The basic idea behind this is to create a self-contained ecosystem, okay, that could potentially support the plant life in the harsh conditions of Mars, where the atmosphere is thin, very thin, and the temperature are extremely cold, and the surface is exposed to high levels of radiation. So this is the basic diagram. You can see I hope it is visible. Yeah. Actually, humans have four vital needs in the space: the breathable air, the clean water, the nutritious food, and the recycling the waste. So for this, the biogenerative life support system is the best solution. It is to use the plants and the microbes in a self-contained system to recycle waste and regenerate it into the air, water, and food. These are the basic needs. Now, how the lunar greenhouse works. You can see in this diagram in the form like a single greenhouse unit would it fulfill the 100% of a crew members oxygen needs. In the second diagram also you can see in the crops, which helps to reuse the 100% of water. And in the third diagram you can see the 50% of one person food that could be grown, and it reducing lands of Can you hear me?
Yes.
Yeah, okay. You can see that in deployable, it is designed by the Arizona State of University of Arizona. It provides a sustainable vegetarian diet for the astronauts, which is most important part of their daily routine. The deployable greenhouse, which can be used for air revitalization, water, or the waste recycling. The idea behind this basic diagram is the carbon dioxide, which exhaled by the astronauts, to be introduced into the Martian greenhouse, which is then used by the plants to photosynthesize and generate oxygen. So this is known as the biogenerative life support system, which is I mentioned the previous slide. Now, this is again one of the best diagram. We can see how the greenhouse work in the Mars. We can see in the left side of the slide, Earth's and Martian soil mix which will help plants to adjust with the Martian soil. And the right side, we can see the heat entering into the greenhouse, which will keep adaptable temperature for the plants. And we can see the heat also, sun, the greenhouse, then the Martian soil plus earth soil, and the flow of water. To make the Mars, there are basic needs which are lower temperature and the atmospheric pressure, the high amount of CO2, and the less fertile soil. The biggest challenge for the Martian atmosphere will be our plants will face many difficulties to adjust in the Martian atmosphere. So, this low temperature, a greenhouse can keep adjustable temperature in it. There is almost 95.97% carbon dioxide on the Mars. So, because of huge amount of CO2, we can use some plants which can adjust under rough conditions, and it can absorb the CO2 more and more. This diagram shows this structure of the earth and Martian soil and greenhouse process. Now about the soil, Martian soil is not that much fertile as like earth soil. So if we suppose if we mix the both soils, the Martian soil and the earth soil, then the Martian soil will inherit some of the useful characteristics of earth soil, such as, for example, decomposing. This is one of the characteristics. And so what will happen if the Martian soil absorb the decomposing characteristics? The fallen leaves from the plants will continuously be decomposed, and then the Martian soil will grow the fertile. Yeah, this next. Martian technologies are the necessary facilitations. Yeah. Applied technologies are the biotechnology. For example, the plant and the soil testing, cultivation. We have the soil samples. Then the microbiology, again microanalysis of the soil and the soil microbiome. Next, the data analytics. Again, wireless communication, the storage of plant data, and the 3D printing, which is the plant-based 3D printing. Okay. And then the next one is the possible resources to generate the in situ resource utilization or transported from. In situ utilization, which is in situ, we call in situ. Water on Mars. First point on Mars. The water on Mars could be very salty, and the result is low freezing point because of it is salty. Again, next point is Martian soil, mixture of rock, dust, sand, and other particles is the Martian soil. What about its primary composition is silicate-based minerals are present in that composition. Then again, the same point which I mentioned in previous slide, the Martian soil and earth soil. The lack of significant amount of liquid water. So that's why we use a mixture of the Martian soil and earth soil. Next one, the atmosphere. The atmospheric pressure, oxygen levels, carbon dioxide, and the tracing of the gases. And the next is the temperature, the optical temperature, the range of the temperature. It means a day-night temperature. The temperature regulation, that is a changing in temperatures. The microclimate, considering light, etc. Next is the greenhouse attributes. The structural integrity, insulation, radiation shielding, lighting system, atmospheric protocol, water management, soil substrates, contaminant, and biosecurity. I want to add one more point. If you want to read more about the radiation and the climate changes, you can refer my research paper from the, you will find my all the research papers there regarding colonization and growing green on red planet and the climate changes, the radiation, all these research paper you will find, and you will get the whole information in that. Yeah. Coming to the next point, management. Can be the organizational structure. First is comes the greenhouse manager, then the researcher, then the scientist, then the technician. Yeah. Green manager. His responsibility is decision making, management, and planning and establishment. What decisions then they have to plan, they have to establish those. Research. Researchers' responsibilities are the crop selection and of course research, environmental control and its monitoring, and the sustainable agriculture. Next, the science. Growth of experiments and innovations. Scientists must have to innovate his new ideas, and then must be experiment on these ideas, and then the conclusion results. So it will be helpful. Maybe his ideas will be helpful in future. And the last is a technician. Technician must collect the data, then his basic technical duties, and highly automated greenhouse service. Astronaut training program. Sustainable human presence. The human presence space is most important topic. Maintenance and sustainable habitat operations. The habitat operations are also the missions which are helpful in the future missions. The support for the launch. Again, this point you will find in my research paper, which I already mentioned in briefly in my research paper, the isolation, the radiation effects on the Mars, Moon, its colonization, greenhouse, or on the climate change, their effects. With the help of small satellites, how I briefly explained in my research papers. Again, astronaut duties are the meeting for the crew decision making. What the crew will take the decisions, and their meetings. Maybe he can suggest, give some suggestions. Then astrobiology and the nutrition. These are I found 2 links regarding the YouTube videos of this astronaut training program. Yeah, resources necessary 1 week. If we saying, suppose we consider if we send 5 astronauts, 2 astronauts, or 3, 5, 7, 6, anyone, required food for each astronaut and required food for individual intake and for 1 week. These are 3 categories. So according to that, we have to provide that much of food and the water, that amount of food and water. So if we send 5 astronauts, then we need each astronaut's requirement. We have to check each astronaut requirement, then his individual intake, and then required for the 1 week intake. Same with the water and food. Yeah, the required guidance to provide the other facilities. The creation of procedures and the protocols for use in each facility, microproduction for food. Sorry. Then the regular and thorough technology development. to enhance the crop growth and food processing. As per as per my research, we need to improve again new ideas to processing the food in the long-term missions like lunar mission, Mars mission. Now in my company, I'm giving example to you. In my company, in Space Nation, we are working on the lunar food production system, and I am the research head in that department. And currently we are sending 3 people to the lunar training program, where we are preparing the space food, which is maybe the space cake, then the space ice cream, such kind of food processing or food innovation be required on the lunar and the Mars missions also. The basic instruction and the training should be included to the astronauts' daily routine for handling and maintaining the biosystems. Yeah, these are the basic instruction and training should be must be most important to all the astronauts, to their daily routine, how to handle and how to maintain the biosystems. Next is the protocols. The basic protocols are firstly monitoring their daily routine, reduce workload and conduct related to related to which at a high level of efficiency. We are also I'm working on the how to reduce the stress of astronauts in the space, lunar, moon and Mars. What can we do for that? Maybe it is we can say that and yeah, normal family calling, the other activities, yeah, they do already astronauts doing these activities. But what can we do in the innovative to reduce their stress level? I'm working on that, and yeah, we'll see how can we reduce the astronaut stress in another way. Next, maintain the biosystem, preventive maintenance and the good condition of the cultivation beds. Biosystem prevention is also another one of the most important part of the long-term missions. We have to compulsory maintain our biosystem in the long-term missions, that is moon, Mars and space. Then collect data and make a report. What we are doing in space, Mars or other lunar missions, collect that data and make a report, so we can divert your mind from the stress level. Then food production protocol, then food system maintenance protocol, then again space food system. Again, I mentioned before that space food system is that topic, that space ice cream, space cake, other meal what we can easily process in the space or the Mars and the moon. So this is the space food system. Then food processing, how we process these type of foods, and the greenhouse building. These are the basic protocols. Next, protocols for safety, radiation protection. The greenhouse structure should incorporate shielding, radiation exposure to both plants and humans. Okay, then the pressure regulation. The pressure regulation is the greenhouse which need to maintain a higher internal pressure to ensure that the atmosphere inside is suitable for plant that growth and human habitation. The pressure and radiation. Next is the temperature control. The greenhouse would need that much efficient heating systems, which maintains a suitable temperature range for the plant growth, which is required for the plant growth. Sorry. the safes and the redundancies that should be in the place to prevent overheating or the freezing. Next is oxygen and the carbon dioxide levels. Plant growth that relies on the exchange of gases like oxygen and the carbon dioxide gases. The protocols that would be necessary to monitor and regulate these type of these gases, that is carbon dioxide and the oxygen gases levels, that ensures a healthy atmosphere for both plants and the humans. Next is the water management. Recycling system for the water management. A recycling system for the water is used. Irrigation and within the greenhouse environment would need to be established. And the protocols that should address water conservation, filtration, and potential sources of water, such as regolith derived the water. Next is the fire safety. Yeah, fire safety is a measures that would be need to be implemented to prevent, and it contains fires within the greenhouse. This one is the most important point. Contamination prevention. It avoids introducing earth organisms to Mars, and it other planetary protection, that is stringent management, contamination and prevention protocols would be necessary. Second last is the emergency protocols. Routes emergency that protocols that should be in place to handle unforeseen situations, such as the system failures, the leakages, the equipment malfunctions, or the health emergencies. These kind of emergencies may occur on the Mars or in the lunar missions. So emergency protocols are required also. And the last one is the power supply. The greenhouse would require a reliable power supply to operate the lighting system, heating system, the ventilation, and other systems. The backup power systems and protocols for maintaining these power generations and storage should be established. Specific times for various tasks such as planting, harvesting, maintenance, and research, which to prevent overcrowding and next is occupants. It defines maximum occupants for areas greenhouse, which ensure that the space is not overused and there is room for individuals to move and move for comfort. This is the occupancy limit. As you can see, IS that it is a limited space, or we can move here and there very congestedly, or you can say congestedly, but as there is no atmospheric pressure, there is no gravity, so we can fly over there. So this kind of occupancy limits. Next, the personal protective equipment, is PPE. Determine whether specific as the clean suits, obviously space suit in the space are required in certain areas, which is to minimize contamination risks. Next, another most important part is hygiene and sanitation, which is most important part in the missions and sanitation. To establish these protocols for maintaining the personal hygiene including the hand wash and the cleanliness, to prevent the spread of pathogens and contaminants within the greenhouse environment. So hygiene and sanitation is a key part of the mission. Second, emergency evacuation. To develop the clear evacuation routes and the protocol in case of emergencies, to ensuring that all occupants are familiar with route and the assembly points. These are the emergency evacuations. Last, entertainment equipment. Again, entertainment equipment is important key part of the long-term missions to reduce the astronaut stress level. It provides to access the entertainment resources such as reading the books, movies, music, and virtual reality experiences that helps occupants relax and elevate their stress. Yeah, now protocols for food microproduction. Selection process, then the plant growing medium, again nutrition management, water management, how the water management, recycling, then the temperature and humidity, then light and energy. So in the part of light and energy, we can I can also mention that I have to mention that the backup energy part. So this is also required. Then pest and disease management, then growth monitoring, how the plants are growth, it must be monitored in the mass, then harvesting and the rotation, again waste utilization, to keep all the record, that is the record keeping, then training and skill developing, and again last, research and the innovation. Must be research and innovate your ideas. As per my study, it is a site selection and preparation. For example, as I mentioned before previously, that I'm working on the lunar. We select such kind of sites which are similar to the lunar atmosphere, the lunar conditions. So site selection and its preparation are the is the first point. Then material selection, which is the most important, how you will select your required material. This related to material selection, you can find you will find this paper also, the maybe chemical something is the title of that paper. You will find in ResearchGate, my ResearchGate account. Then the again printer calibration, then testing, then design modeling, how you design, how you model that. In the part of design and modeling, I will mention one of my example is as we are preparing the sounding rocket. So this is the best example I have to give how to do this. As we firstly we did some software work in that required measurements, then how to design that on the how to design that rocket on that software, and how long that sounding rocket must be. And then we will go on the modeling. We'll make some we will make the model of that rocket, and then we will test that sounding rocket. So same process is in the design and modeling. Then printing process, the quality control, the structural reinforcement. These are the protocols for the 3D printing, that is energy management, again waste management, emergency response, post-construction inspection. Post-construction inspection is what? If you construct some a dome or on the Mars or the lunar or in space, then inspect that construction or monitor that construction. It works well or not, is like that. The sealing and insulation and the integration of that components which you use in that model. No, yes, the technologies and outputs that could be applied to Earth. Plant and health monitoring, again the same, the plant and health monitoring. If you want to grow some plants or if you need new tech improvisation on your health on the Mars and the lunar missions, then you have to continuously monitor and make a report based on that, how the plant and health or the work in the space or lunar and the Mars. If you divide in this way, then you will get a better report how it monitor in different conditions. Then alternative energy resources. Yeah, this is the important part. Alternative energy resources are required. And the recycling technologies. Recycling technologies are required for the waste management based on the water, food. So if you recycle these water and food, then how you will recycle based on the new technologies? What can new technologies you can use in for this water and food recycling? Guidelines that could be applied to daily life on Earth. Health and safety. Health and safety, yes, are the most essentials on Earth and Mars also, or the lunar also, and or long-term missions. They both are important, the key parts of daily life. Education and healthcare improvisation. Education, we need better education regarding. I will give an example. I'm giving the example, the normal example, that we require a space education more and more efficiently, because where I'm living in the small village, giving example in my village, I'm living in the small village where not a single person know about the space, what is aerospace, and this. As now I'm in this field, field of space. Now they are know about the space and aerospace, telescopes, the planets, the moon, Mars. So this kind of improvisation in education is needed in the daily life on Earth. And last, the healthcare improvisation. As mentioned in the first point, the health and safety are the key points. So we need to improvise our healthcare in the daily life. We need to must concentrate on our daily life healthcare. The last impact to sustainable development goals. The hunger and the clean water and sanitation, affordable and clean energy. Then industry, innovation, infra. How is your infra? Then your innovative ideas. Suppose is there anyone if there any industry, then how that industry works in innovative ideas. Then sustainable sites and communities, responsible consumptions and the production, how you will produce that some or any product or something like that. Then the climate action, life on land, and peace, justice, and strong institution. I want to add one point on the peace, justice, and strong institution. As my uh, small sentence about the space is space for humanity. So for that, as per my opinion, space is that medium to come closer for that. Because of the space, there are people around the earth or whole world can come closer for the space. That's why my most important slogan for the space is the space for humanity. We have the peace, which is a key in our daily life. We need peace. That's why the space for humanity is my slogan for that. And last, partnership purpose. If we want to achieve these goals in the field of space, then we have to be must have partners with different organizations, institutions, industries, and other space agencies. So we can collaborate with each other and to achieve our goal. And we never know. We never know that the space for humanity goal will be achieved. These are the references, the space management, space greenhouse, the solution of feeding that astronauts on the journey to Mars, and the project on Mars. This one is a great. I read that paper, and the inflatable greenhouse for the sustainable farming on Mars. Yeah, this is my personal contact and social media details. You can follow my Instagram page, Shreya or you can email me on the both email IDs. This is my LinkedIn profile. Thank you so much. Thank you for patiently. Thank you.